Hello and welcome to my channel. In this video, I'll be covering Credit by CS50's Introduction to Computer Science. So let's get started. First, I'll be giving a rough overview of what we're supposed to do in this problem set, which is already given in the walkthrough in the to-do section. So first we prompt the user for their credit card number, and then we calculate the checksum, which is using the Loon's algorithm, and then we check for the card length and the starting digits, and then we print Amazon Express, MasterCard, Visa, or invalid. So this is a pretty long coding problem, and it might take a while to finish this video. I have uploaded this video previously, but I feel that it was pretty badly done, so I'm creating it for the second time around. So let me just download the files that are required for this problem set and we can start. Alright, so I've just downloaded the files that are required and we have credit.c. So let's start coding up our file. Alright, so the first step is to prompt the user for an input. So let's just prompt the user user input equals to, and this time we can't just get int because the user input is going to be pretty long, so we have to use get long instead. So get long. Yeah, so the int data type would not be able to handle so many digits. I think the maximum number that the int data type can store is 2 billion, and if it's any more than that, it can't store it. And of course, these numbers are more than 2 billion. So get long, we prompt the user for the number. Okay, so that's nice, and then of course we have to initialize this to a long, and that's about it for prompting the user. Now we have to calculate the checksum. So this is where the problem turns into a pretty difficult problem set. So to do this, I was wondering perhaps we could use a function so that we don't have everything in the main function. Alright, so we are passing into this function the user input, so long user input. I mean, we can call it something else like number so that we don't confuse the two variables here because they are two different variables. And then we are passing into this the user input, and then we return the checksum. Actually, we could return a boolean to return true if it's the correct checksum and false when it's the wrong checksum. And what I mean by that is, after using Loon's algorithm, we should be able to get a number that ends with a 0. And if it does end with a 0, we return true, and if it doesn't, we return false. And we print invalid, and we just exit the program. Alright? So yeah, it's gonna be a bool. So let's type in our function. Alright, so how might we want to do this Loon's algorithm? If you read through this, it should be pretty simple to understand as well as the walkthrough. So we multiply every other digit by 2, starting with the number second to last digit, which is these few numbers here. So we multiply them by 2 and we add the products of each of these digits together. So it's gonna be 1 times 2 plus 0 times 2 plus 0 times 2, and so on. And for example, if we have 12, we have to separate out 1 and 2 and add them together. And then those which weren't multiplied by 2, we have to add them into the total. So let's just first create a variable called total, and we can initialize it to 0. And let's create a while loop which will be in while doing this Loon's algorithm. So for the first digit here, we will not be multiplying it by 2, so we can just add it to the total. Total plus equals to num modulus 10. So if you watched the walkthrough, this should be pretty simple to understand. When we modulus the number, we would be able to get the last digit of the number. That's because when we divide this number by 10, the remainder would be the last number here. So that's how we get the last number, and we will be adding it into the total. If you don't know what this operator is, it's basically the shortcut of doing something like this. Total equals to total plus this. Alright? So it's basically taking the original value of total and adding this number into it. Because we want to have the original value of total and add on to it in every single loop and not lose the value. So we'll be doing this. To read up more about this operator, you can just give a quick search. So to learn more about this operator, you guys can just quickly give a Google search like C programming shortcut arithmetics, and you'll be able to see a bunch of them. And this is the one we are using. Alright, so yeah, give it a quick read if you're interested, and it comes in pretty handy. You see how we can make this into a short form like that? Yeah. Alright, so this is how we get the last number here. However, when we want to get the next number here, what we have to do is divide the entire thing by 10 to just remove this 4 from the equation. So let's take num divide equal 10, and there's another shortcut to just do this here. Okay, we are just dividing num by 10 and then inserting it back to num. Okay, so now we have the 4 removed from this equation, and then now we are left with 1, and when we are at 1, we want to multiply it by 2. So let's do that. And how I personally did that was first initializing a variable, a bool variable, bool_var equals to true. So here, when we are at the first number, this variable will be equals to true. So we check if the variable is true, and for the first number, this variable will be true. And in this case, we'll be entering here. Alright. Then now we change the variable to false. And then for the next loop, we'll be entering this, because if it's not true, then it's going to be false. This time around, we want to multiply it by 2. Okay, so total. Actually, you know what? We are not going to do this method here. We are going to instead put it into a buffer. And I'll tell you why later on. Buffer equals to num divide num modulo 10. And now the last number here is stored in this buffer. And then now we want to multiply the buffer times equals to 2. So we want to multiply this buffer by 2. Now if the buffer is more than 10, then we want to split this number into 2 numbers so that we can add them both separately. For example, 12 is more than 0. We want to separate the numbers and add them both separately. So if it's more than 10, we take buffer, we take total plus equals to buffer modulo 10, and then total plus equals to buffer divide by 10. So we'll be getting this 2 here when we modulo it, and then we'll be getting this 1 here when we divide it, because when we divide it, we're removing this 2 from the end. So that's about that. And then if it's not more than 10, else we are just gonna total plus equals to buffer. In case you guys don't understand what this plus equals to operator is, just comment down below and I'll give a brief explanation, or I'll link to a page which I feel gives a good explanation. And similarly for this and similarly for this and this. So yeah, I use these shortcuts quite a bit. So yeah, and it's quite efficient and effective as well. Alright, so now we have total. Okay, that's the total is basically the total number that we get after adding in all the numbers after doing this Loon's algorithm. So yeah, oh okay, so I just saw a bug. So you know how for the first value we'll be entering this because variable is true, and then after the first loop we'll be entering this because the variable is not true anymore because we changed it to false. So this time around we have to change it back to false, because back to true, because we want it to enter here, because the next number will not be multiplied by 2. So var equals to true, and that's all. Now we can just give it a quick run to check if it's working fine. Oh yeah, just skimming through if I forgot some of the semicolons. Alright, looking fine. And yeah, I forgot to initialize this buffer. Alright, yeah, looking good. Let's try to make credit. Alright, just like I expected. Okay, so we have a problem here. So at one point, oh okay, I just saw another bug, which is we want to, after all this is done, we want to divide the num by 10 so that we remove the last digit from the equation, so that we remove, and then we'll be able to see the first few digits as for our problem to work. So yeah, just like what we did here, we have to do it at the end of this else. Alright, yeah, okay, looking fine. And yeah, the while. Okay, so the while will run this Loon's algorithm as long as the number is more than 0, and when it's not more than 0, we'll be just stopping the equation because we are done with calculating all the numbers. So if while num is more than 0, alright, and then oh sorry, not code credit, it's gonna be make credit. Okay, we have an error. Non-void function. Alright, so yeah, we just forgot something, which was because our function is a bool, right? So we have to return either true or false. If the total's last digit is 0, the number is valid. If it's not, then it's not valid. So let's give it a quick check just after our while loop. So if total modulo 10 is equals to 0, then we return true. If not, we return false. Why I don't have to put the else is because if this is true, we'll just return true and we'll just exit the loop. However, if this does not return true, then we'll be able to come here. And if we are able to come here, that means that the modulo is not equals to 0. Alright, so make credit dot slash credit. And just before ending, let's just print out what the total is. %i for integer total. And let's just end it off with a \n, and let's just try to make it a bit more visually pleasing. And we can just use this example which they gave us earlier. Let's try this number. And oh okay, we have to make it again, dot slash credit 20. Wow, so damn, we got that right. Okay, so yeah, because you see how this is 20 and ours is 20, so we can confirm that ours is correct. And in the case where it's false, we want to do something else. What we want to do is print invalid like \n, and we return false, and that's about it. Okay, so now the next step is to check the card length and starting digits. Okay, so to check the card's length, I thought we could use something that we use in the checksum method. What we could do is we could just divide the number by 10, and we add a counter in this loop, and when it's 0, then we can check for the counter number. Alright, so let me just code it down so that you guys can understand it better. Digits equals to 0. I'll just initialize it to 0. I think it's a good practice, I don't know. In digits equals to 0, and while user input is more than 0, we want user input user input equals to divide equals 10, and then every time that's happening we want to increment digits plus plus. This is another shortcut to add 1 to the digits. Alright, so this loop will be occurring as long as the user input is more than 0, and every time we run this loop we are removing the last number from this from the user input. Alright, so first time we run the loop we remove 4, next time we remove 1, next time we remove 0, and so on and so forth. Okay, so let's print out the user input, I guess. I mean the digits, %i digits, to check if our digits are correct. And this is end off with a \n at the back. Alright, so make, oh no, yep, of course, missing semicolons all the time. Make, oh no, oh my gosh, yeah, okay, sorry about that. Been doing Python. Okay, oh no, make credit, oh finally. Let's just use the David Mellon's Visa card number. Digits 16. Okay, I think that's correct because Visa is either 13 or 16, and it seems like we have done it. Okay, so we have came up with the number of digits for this Visa card number, which is spectacular. Now we have to move on with getting the starting digits. Alright, so for American Express is 2 starting digits. For MasterCard it's 2 starting digits. For Visa is 1 starting digit. We could utilize this while loop to get the starting digits. What we could do is at the very beginning we check if user input is more than, if user input is less than 10, then we can just take single digit equals to user input. Yeah, so when we are dividing it by 10, then if we are remaining with 1 single digit, then we can just get a single digit. And then next we can check if user input is more than 10, alright, but which is the AND operator, user input is less than 100. So now we know it's 2 digits, alright, and then we can just save it as 2 digits is user input. Okay, that's awesome. Let's just initialize them because we don't want the stupid errors popping out. Okay, single digit, and now we have 2 digits equals to 0, and that's about it. Let's try to make credit, and we could give a quick check on what the single digit is and the 2 digit is. Single digit, 2 digit, 2 digit. Then let's just give it a quick check, /credit, and our number is this David Mellon's Visa card number. Single digit 4, 2 digit 40 works perfectly fine. Alright, now let's do the fourth and final step. Print American Express, MasterCard, Visa are invalid. Okay, so for American Express, 15 digits starts with 34 or 37. Okay, so now let's check if 2 digit is 34 or 2 digit equals to 37. And along with that, a compulsory check that we have to make is that the digits is 15 digits. So this has to be true, and along with that we want to make sure the digits are 16. Okay, So if either one of this is true and if this is true, then we'll be entering this if condition, and we can print F American Express. Awesome. Alright, and cool, and then we can just return 0 or something, and then now we can just else if MasterCard. So for MasterCard we have 2 digits as well, so we can do something like this. Else if 2 digits equals to 51, 52, 53, 54, 55. Wow, that's a lot of damage. Okay, so if either one of this is true and the digits is 16, wait, what? Okay, sorry, this is supposed to be 15. Yeah, and MasterCard is 16, American Express is 15. And then we return MasterCard \n. Awesome. Else if now we want to check the single digit. Alright, so let's check it out. Single digit. Sorry. Oh no. Single digit equals to 4. Okay. And digits is either equals to 13 or 16. Okay, so either 13 or digits equals to 16. Okay, so that seems about right. We can just do a quick check and see if everything's fine. Sorry, we have a few more steps. Was getting ahead of myself. Return 0. And if neither one of these cases satisfy, we want to print invalid. And if it's only one line, we don't need this ugly curly braces. So let's just copy this and paste it here, and to end everything off we can just return 0. We don't really have to do this, but I don't know, just do it anyways. Okay, so make credit, errors, semicolons of course. Anything else? No, doesn't look like it. Make credit, semicolon, I see. Yep, my bad. Make credit, / credit, and let's just use the original number here, the OG Visa. Okay, seems about right. Let's just give it a quick check 50. Oh no, we have some errors. Expected EOF. What's this? As invalid. Okay, invalid. Okay, so what's the matter? Okay, you know what? Let's just try out some of the things that they mentioned. This number, for example. Oh no. / credit. Invalid. Okay, it's invalid. What's the matter? Oh, okay. It runs invalid twice, I guess. Is that the problem? Okay. Yeah, I think that's the problem. Check some. Yeah, that's the problem. Sorry about that. So the problem is, after we return true or false here, we have to kinda shut this problem set out. So we check some here, and yeah. So if oh my gosh, Yeah, I just missed an entire chunk of code. Checksum equals to checksum underscore sum. This is where we store the value true or false that we get from the checksum. To see if it's divisible by 10 like they mentioned here. If the total large digit is 0, the number is valid. So yeah, if the number is invalid, we want to just cancel out the entire code. So if checksum is equals to false, then we just want to exit away from this. So exit 0, exit, okay. Yeah, we have to initialize this checksum variable that I just randomly defined. That's all, I guess. Let's just check 50. No, not check 50. Make credit. Okay. So we have a problem. Is it return? Could we just use return? Return 1, I guess. Let's try. Okay, seems like it's working. Okay, wow, okay. Yeah. So what was this exit thing I was trying to use? Exit is just like return. It's basically the exact same thing, but exit, I guess, just shuts off the entire program, but then return just returns to the main function or something. It's not really very important. It's almost the same thing, alright? It just exits the code and program. Yeah, let's try to check 50. Okay, so it seems like it expected 0 and not 1, so let's just change it to 0. And they didn't even tell us. Yeah, they didn't even specify what exit number they wanted in the problem set, so why are they asking for that? I think exit 0 is, I don't know, man. Check 50 again. Make credit first, check 50. Okay, so 555 is okay, so we have one last and final error. So let's just take a quick look at what they're saying. Expected MasterCard and not total 114. Huh. What's the problem here? MasterCard. Seems like it's not detecting MasterCard or something. Let's just take a quick look. MasterCard. So this number is not working. Let's try this number out. Invalid. Okay, total is 114. So this total is printing out 114, and of course when it's 114 it doesn't end with a 0, so it will return false. But I don't think they expected it to be. Oh, okay, sorry about that. It's supposed to be more than or equals to 10. Okay, yeah, that was my mistake. More than or equals to 10. Okay, now it should be working fine. Dot slash credit. Oh no. Oh yeah, sorry, we have to make credit first and then dot slash credit, and there you go. MasterCard. And finally, we might have just solved this problem at the very end. And so yeah, to conclude this video, if you found this video helpful, beneficial, or fun to watch, hit the like button and consider subscribing. And if you have any questions or any comments, do comment down below and I'll try my best to reply to your comments. And thank you both and thank you very much for watching my video. Alright, so everything's working fine. I'll just be submitting my code and have a great day ahead. Bye bye.